So some people requested some examples of speeding up and slowing down with various velocities and accelerations. So here we go. Let's start with this example where we have a car whose initial velocity v naught is positive 20 meters per second. We're taking to the right to be positive. And then later, the velocity is positive 30 meters per second. And let's say, just to give, that we can give numbers on this, let's say that the time that it takes to make this change in velocity is 4 seconds, 4.0 seconds. Right now, without doing any calculation, I should be able to say this car is speeding up. Right? It starts with a magnitude of its velocity of 20 meters per second, and then later the magnitude is larger, 30 meters per second, so it's speeding up. Right? You would have to step on the gas to make this change, not hit the brakes. So if I want to calculate the acceleration, then I can say, well, the definition of acceleration is v minus v naught divided by t. So my velocity v is 30 meters per second, and I subtract the initial velocity, which is 20 meters per second, and divide by the time, which is 4.0 seconds. Right? So now the change in velocity 30 minus 20 is 10 meters per second divided by 4.0 seconds. And that gives me that the acceleration is a positive number, right? A positive divided by positive is positive, and that gives me positive 2.5 meters per second squared. Right, so that is an example of speeding up with a positive acceleration. Okay, so now let me copy this original picture here and make a duplicate down here. And let's change this up a little bit. So instead of going from, let's make the final velocity something different. So now the final velocity, still moving to the right, but it's at a positive 10 meters per second. Right now I can look at this and say that's slowing down. Right, the magnitude of the velocity, or the speed, is getting smaller, closer to zero. Okay, so again, same definition for acceleration. Acceleration is v minus v naught divided by time. And that's going to give me 10 meters per second minus 20 meters per second divided by, again, we'll still take the same time, 4.0 seconds. And now that's 10 minus 20. That's a negative number. 10 minus 20 is negative 10 meters per second is my change in velocity. Again, divided by 4.0 seconds. So my acceleration now is negative 2.5 meters per second squared. Right, and that unit there, if I look at meters per second divided by seconds, that's meters per second, which we call meters per second squared. Okay, so that is slowing down with a negative acceleration. And that's because in this case, the velocity is positive and the acceleration is negative. So if those have opposite directions and therefore opposite signs, that means slowing down. Right? So negative acceleration does not automatically mean slowing down, but in this case, it happens to be true. All right, so now let's mix things up a little bit. So if I paste my picture here again, so now we still have the positive sign being to the positive direction being to the right, but let me now erase these things. Let's say now that the car, and one benefit of drawing a bad picture is I can just say, well, let's if I just erase a little bit, oops, and erase a little bit, there. Now the car looks like it's going to the left. I don't know. It's one of those Elon Musk Cybertrucks. So here the car is going to the left in both of these pictures. So since it's going to the left, now the starting point is this one here over here. So that's the initial velocity. So because it's moving to the left, that means that the velocity has to be negative. So let's say that it starts with a velocity of negative 30 meters per second. And then later, it's going negative 50 meters per second. So this, just to make it super clear, this is before over here, and this is after. Right. So now I should be able to look at this again and say, okay, it starts negative 30 meters per second, but what would your speedometer say? It just gives a magnitude. So it goes from 30 to 50. That means it's speeding up. I can tell just by looking at that description. But I can also calculate the acceleration then is going to be, again, v minus v naught over t. Always have to show your starting equation. And that's going to give me, so v is negative 50. Now I have to be careful here working with negative numbers. Let me move this down to give myself a little space. So I have to be careful when I'm working with negative numbers. So negative 50 minus a negative 30 meters per second. And that's, again, we're using the same time for all of these. So 4 seconds. So negative 50 minus a negative 30 is the same as negative 50 plus 30. That gives me a negative 20 meters per second divided by 4.0 seconds. And that gives me an acceleration that is negative 5.0 meters per second squared. So that's the value. And I have v is negative, a is negative. So that's still speeding up because they have the same sign. So that's speeding up with a negative acceleration. Speeding up even though acceleration is negative. All right, and so one more example left. Right, there's 4 different possible combinations, so might as well do all 4. So let's start with starts with negative 30 meters per second, and then let's just say as an example, it comes to a stop. Right, so negative 30 meters per second, and then it ends at 0 meters per second. That's got to be slowing down, right? You slow down to a stop. So let's calculate the acceleration. Acceleration is equal to, again, v minus v naught divided by the change in time. Again, we'll say that this took 4.0 seconds. So v minus v naught, I've got 0 minus, again, be careful with that minus sign, minus a negative 30 meters per second. divided by 4.0 seconds. So 0 minus a negative 30 is a positive 30 meters per second divided by 4.0 seconds. So my acceleration, 30 divided by 4, is 7.5 meters per second squared, and that's positive. Now, sometimes I'll put the positive sign there just to emphasize. Of course, it's not necessary. So positive 7.5 meters per second squared. So acceleration is positive, but the velocity started out as being negative. So that means it's a case of slowing down with a positive acceleration. Right. So those are the 4 examples of, you can either be speeding up or slowing down, and whether the acceleration is positive or negative depends on which way you were going, and which direction is defined as positive.